Guys, if you want to be successful with your machine learning operations, you need to be successful with your machine learning platform first. You see, running a machine learning operations is like running a Formula One racing business. In order to be successful in Formula One racing business, you basically need three things. You need a car with a top-notch ergonomics, such that it's easy to drive for the drivers. You need a car built from a cutting-edge technology, such that it's powerful, reliable, and easy to maintain for the engineers. And you need this car to generate return on investment, and that happens by winning races and selling commercials. And likewise, in order to be successful in the machine learning operations, you need a machine learning platform with a top-notch ergonomics, such that it's easy to use for the data scientists and for the machine learning engineers. You need a platform built from the cutting-edge technology, such that it's scalable, reliable, and easy to maintain by the platform team. And you need this platform to generate a return on investment from turning machine learning models into machine learning products. But establishing such a platform nowadays is not an easy task. There are literally hundreds of different eligible tools, and there is no such a thing like off-the-shelf platform that you just pick and plug and play and it's gonna run happily ever after. So there are these hundreds of tools that needs to be stitched together by your platform team. And in order for your platform team to do it properly, you need to give them proper requirements. And since like 80% of you guys on the other side of the screen are machine learning experts, so data scientists, machine learning engineers, etc. So actually the drivers in this analogy, you are responsible for setting up these requirements. And you are responsible for sending feedback to the platform team. So the purpose of my talk is to help you a little bit by giving you three areas of requirements that will make your machine learning platform a success. And these three areas cover tooling, the ergonomics of the platform, and return on investment. All right, so let me start with the first set of requirements, and that is about the selection of the tooling. Now, machine learning tooling is constantly evolving. There are currently roughly 300 machine learning tools on the market, and the number is going up as we speak. There are at least 6 machine learning frameworks that I can think of that you guys like to work with. And there are 5 typical scripting and coding languages in which you like to develop your stuff. And then you also need to host this entire stack somewhere. And either you host it on cloud or on premise. And both of the options, they have their pros and cons. And if this does not sound complex enough, then I can go on like this. I can go on with orchestration frameworks, with workflow managers, with inference tooling, and so on and so forth. So what I'm trying to say is that there is immense amount of possible ways how you can assemble together the machine learning operations platform. So what are the things that you should actually ask for? What are the ways to survive in this jungle? Well, I can think of at least like 4 directions to think about this. So the first is about legacy of the tooling. You see, tools, they come and go. And so do the companies behind these tools. Like roughly 2/3 of those 300 machine learning tools that I mentioned, those are built by startups. And the rate of failure for startups is something like 90%, like 90. But it's not only startups. The big ones, they fail too. Does anyone remember Hortonworks? That used to be a big name. There was a company behind the Hadoop. Well, these guys are not around anymore. So just think where your favorite tooling is going to be in 2-3 years from now, or if it's going to be around at all. So the first thing to ask for your platform team is to have a platform that is able to adapt quickly to this ever-changing zoo of tooling. Now, as I mentioned, the way how these platforms are set up is that you are stitching together dozens of different tools, which creates kind of a web of interlinked tools. And in between these tools, you need to exchange information somehow. And for some types of information, like for data, for instance, this is kind of a solved problem. With models, that also works kind of fine. So you have certain standards of how you can exchange machine learning models between different machine learning tooling. So you have things like PMML, ONNX. You can wrap your model in a Docker container and ship it like that. So that's fine. But then there are other types of information, like for instance, metadata. And for this type of information, there are no standards at all. So if you choose for one type of a tooling, for instance, I don't want to pick names, and then you choose for a next one because you find it better in some time, since it's all evolves, then you will have to do certain migration of this metadata, of this information. And that's going to be hard. So what you should aim for is a minimal hassle when migrating your work between the tools. Because every minute you spend more on migration, you actually spend less on data science. And it's data science what you should be doing. Now, continuing in my story with this patchwork of different tooling stitched together to create this machine learning operation platform. Another thing that is quite hard is to set up a consistent security, monitoring, and logging from the very beginning. And security is a binary game. So either you have a complete security on your platform, or you have no security whatsoever. So there are no middle grounds. And having no security has huge operational implications down the road. So there are things like you can accidentally delete data or models of your colleagues. Or if you don't have the monitoring, then models are not running, but you don't even notice. So another thing to ask for from day one is to ask for a consistent security, monitoring, and logging from day one. Right, and the last thing is about lock-in. And at this point, some of you might think, well, but don't tell us about no locking because there is no such a thing. And yeah, and I agree with you there. But the situation where you are in a full lock-in, so at the mercy of the vendor, that's also not where you want to end up, right? So always ask for a realistic possibility for lift and shift of your machine learning operations platform, such that you can keep always up to date with the most powerful infrastructure at the lowest possible cost. So it's coming back to the analogy with Formula One, it's a bit like when the Red Bull team has completely changed the engine of the car from one year to another. And they were able to continue next year without any problems. So these kind of situations. So what are my suggestions for the requirements on the tooling? Well, my suggestions are as follows. Be constantly ready. Be ready to constantly adapt and integrate, because the machine learning technology changes fast. Aim for security, monitoring, and logging from day one. And treat infrastructure as a commodity. And a great way to achieve this, in my honest opinion, is to build the foundations of your platform on the cloud infrastructure, which doesn't mean that it has to be hosted on the cloud, and on Kubernetes. All right, so that was the part of the non-functional stuff, so things related to how to select tooling in your platform. Let me now go to the second point, and that is about the ergonomics of the platform. Because you see, when you sit behind one table, different types of people, machine learning engineers, data scientists, IT architects, managers, and they start to contemplate on how this machine learning platform should look, the discussion gets extremely complex, extremely fast. But the platform is there for you. I mean, you are the driver, so it has to feel right, right? And so if you think about it, there are actually 3 levels or 3 layers of ergonomics to think about. So on the deepest layer, you have to cover the machine learning lifecycle. So those are things like you have to have access to production data from different type of storage services. You have to have proper experimentation tools. So you can train your model, you can tune it, and you can test it. You need to be able to turn your machine learning models into machine learning products. And these machine learning products are really like self-contained web applications with APIs, etc. And for this, you need to have a proper deployment tool. So that's, again, a different tool stack. And then you need to have a proper monitoring tools to be able to monitor the machine learning products that are online. So what you want to cover actually are these four yellow icons. These are the first so-called first-class citizens of the machine learning lifecycle. And what I want you to note is that all of these first-class citizens are actually facilitated by the same construct. And that construct is a pipeline. So those are the tubes below the yellow icons. And pipelines are kind of a Swiss Army knife in your machine learning operations. So when you think about your deep level ergonomics of the platform, think about pipelines in the DNA of it. And ideally, these pipelines are also able to collect and record metadata, because metadata are the currency of machine learning operations. So they give you the traceability on your experiments, etc. And metadata are also kind of enabler for the process management in machine learning. If we go one level higher to the user concept, then we basically, what we want to cover here is that, fine, if you're able if you have your machine learning lifecycle covered, that's okay, but that's for one user. But you normally want to have multiple users on your platform, and you want to shield these users. You want to shield their computational resources such that they are not blocking one another or stealing resources from one another. So think about concepts of a workspace where you can shield the users. But in the end of the day, you want the users to collaborate. You want data scientists to collaborate. And that is by sharing some information, by sharing code, by sharing models and data. And this sharing happens in a kind of a project concept. And if you go to the top level of your ergonomics, you have the environmental concepts. Because what you want to do is you want to host these different projects on the same, in the same kind of environment where all these data scientists are working next to one another. And they are working on different projects. And this environment for experimentation, we typically call a lab environment. But then when they are done, you want to, when they are done with their experimentation, you want them to be able to deploy their models to kind of production. And that's a factory environment where the deployments are running uninterrupted from the experimentation happening in the lab. All right, so to sum up, regarding the ergonomics of your platform, my suggestion to you is to require the following. So require the deep level ergonomics, which is basically the coverage of the machine learning lifecycle. So ask for things like artifacts, metadata, pipelines, and so on. On the mid-level, ask for collaboration concepts, so projects and workspaces. And at the top level, ask for 2 different environments, for the lab, for experimentation, and for the factory, where your machine learning products are running. Okay, so at this point, we've covered the non-functionals, so how to select the tooling for a platform, and the functionals, so how the platform should feel, what are the ergonomics. And the third important aspect, in my opinion, is the economic aspect. Because, you see, machine learning is extremely intellectually stimulating area. But unless you are extremely lucky and you are paid to do it for fun or for research, which I'm certainly not, the majority of us are employed to generate economic value added for your company. And the only way to do this is that the revenues from your platform exceed the costs. So the economic story has actually 2 sides. So you have the cost side on the left-hand side, and then I'll talk about the revenues. Let me first go through the cost side. So what are the things to keep in mind? There are a couple of items. So the first decision when you're setting up a machine learning operations platform, the first thing you have to decide is whether you're going to buy it or build it. And long story short, unless you are a tech titan with army of DevOps people, it turns out that it's cheaper to buy than build. And by buy, I don't mean that you have to buy a black box kind of solution, but you can also pay some company to build this platform for you. There are those kinds of companies. Another thing to keep in mind is the integration of this machine learning operations platform into the rest of the existing IT ecosystem. And here I'm coming back to the story with Kubernetes and cloud infrastructure, because in some cases, this might be a viable endeavor, and you're done with your integration in few months, let's say. But in other cases, if your IT ecosystem is fighting back, this can be a complete showstopper. Another thing to consider are the usage patterns of the platforms. Because you see, there are platforms and vendors and plans where with few users and few models and just experimentation, it's quite easy, it's quite viable, it's not so expensive. But as you start to scale up your machine learning operations, the equation can revert completely. Another thing is maintenance. So think about who is going to maintain the platform. If you buy it, it's easy. It's going to be the third party. If you're building it, though, then your internal platform team has to kind of maintain the platform. And these people, they want and need to be paid too in the end of the day. So don't forget to factor in these costs. And the final thing is the opportunity costs. And this is quite often forgotten. So when you decide to build a platform, it's going to be developed something between 6 and 18 months, let's say. And for this time, you are actually not generating any profits because you're not turning your machine learning models into machine learning platforms. So think about the foregone profit too. And that actually brings me to the positive side of the story. And that's the revenue side. So the first point I would like to stress is aim for machine learning products, not for POCs, experiments, models in your notebooks or drawer, because these are not generating any economic value added. Then the efficiency at which you can turn your machine learning models into the products really matters. It really makes a difference if this takes 2 days or 2 hours instead of 2 months, right? Another thing to think about is the reaction time. So for instance, in times like this, when Corona has struck the market and we have like a structural change in the data, out of a sudden, if you have like 50 or 100 models in the air, they might have become obsolete and you need to retrain them. So, and then whether you are able to retrain fast and deploy immediately, that can be a difference between the night and day, all right? And the last thing is about the scale. So in my honest opinion, the whole game of machine learning operations, it's a game of increments. So you have certain fixed costs of your platform, and then you need to have a lot of models in the air with the incremental value that are going to outweigh these costs of the platform. I really don't believe I don't think there are things like one or two almighty models that are going to just pay for the platform. I never seen that. So what are my suggestions for the economic requirements on your platform? Well, try to limit the total cost of ownership. So that's the sum of the points on the left-hand side. Aim for machine learning products, because it's machine learning products that are generating the economic value added. Start small, but be able to scale aggressively without like skyrocketing of costs. And measure your return on investment from day one. Because there is this managerial quote, if you cannot measure, you cannot manage. So in summary, there are three most important points I want you to take away from this session. The first is, go with the cloud infrastructure and Kubernetes, because machine learning tooling is evolving constantly and it's evolving fast. Think about ergonomics, because the platform needs to feel right for the data scientists. And focus on the return on investment, because without return on investment, you are risking your own job too. So when you go back to your company and start discussing the next platform design, just keep that picture on the right-hand side at the back of your mind. And the benefit of this picture is that it's a platform design that is going to hit the ground running today, and it's not going to be obsolete tomorrow. So guys, this is it. Thanks a lot for your time and attention. If you want to talk more, drop in our Credo booth. I'll be there waiting for you. My name is Rado Parák, and I build machine learning platforms.